Okay, so this concept used to be in the four unit, okay? So what you need to think about, like if I had the x values for f of x, so possible x values could be, I'm just going to make some up, I'm going to quarter, a half, and then I'm going to go to 1, and then we're going to go 2, 3, and 4. So what happens is it's the x values that are changing. So if you went 1 on x, let's just make up a function for this one. So that means that we know that it doesn't start at 0. We know x is greater than 0. And we know that it is increasing. So it would look potentially like that. So if we look at this point at 1, and we just say that was, I'm just making this up, that was 2. So at 1 it is 2. At a quarter, let's just say at a quarter it was about, I don't know, let's just say a half. And at a third it was, I'm just making these up. At a third it was 0.8, and let's just say this was 0.9. Oh no, we probably could say 1.9, couldn't we? So I'm just estimating these from the graph. Okay, so let's just say that was 0.5, then that was this will be 1.2, say, and 0.8. So I'm just literally making these numbers up. So I'm just getting these values here. And this is on the f of x graph. And when it's at 2, let's just say it was at 4, and when it was at 3, it was at 6, and when it's at 4, let's just say it's at 8. Then what happens is, if we flip this, the x values become 4, because you're flipping a quarter, you're flipping a third, you're flipping a half. When you flip 1, you get 1. When you flip 2, a half, 3, a third, and 4, a quarter. So when you're doing the new graph, g of x, which is f of the same as f of 1 on x, what that means is that it's going to have, like when you put in x equals a quarter, on the new graph, it's going to have the same y value as a quarter for the old graph. So that would be your 0.5, your 0.8, your 1.2, your 2, and your 4, your 6, and an 8. So what will actually happen, like if you, for f of x, right, the point a quarter, 0.5 becomes 4.5. Like it keeps the same y value, and the x is flipped. So this is g of x, becomes that graph. And if you go a third would go 0.8, and then 0.8 would go to 3.8. And then if you went a half, 1.2, a half 1.2 would go to 2, because you flip the x and it's 1.2. So they're keeping the same y values, it's just the x is flipping. And the effect of that, if you think about it, so the first one you notice was a quarter went to 4 a half. So that means at 4, which is right up here, it would be at a half. I'll do that one in green. And a third went to 3.8, so 3.8 is down here. And a half went to 1.2, it went to 2 1.2, so 2 1.2. At 1, you notice that it keeps the same point. So 1, 2, because 1 will flip to 1, will go to the same point. So that's going to go like that. So effectively, that's what the graph will do. At the point where x equals 1, it's going to go like that, but then, and that's an open circle there. And here, it's going to intersect at the point where x equals 1. Okay? So x equals 1 is the point of intersection, because they've got x equals a. So when they're talking about all of these, they're talking about what is happening at the point of intersection. So if we think about this, at the point of intersection, that's at 1, because when you do f of 1, that's the same as f of 1 on 1, so it will be the same as g of 1, so it keeps the same y value at the point where x equals a or x equals 1. So if we now look at this, we're actually going, alright, and this is g of x, and this is f of x. So part A says g dash at 1 is less than 0. So that's true, because that just means it has a negative gradient. And the g of x graph definitely has a negative gradient at that point. B, g dash of 1 equals minus f dash of 1. So they have the same gradient, they're just going in the opposite direction. So that's also true. So we can wipe out A and we can wipe out B. If we look at the next one, g dash of 1 equals minus f dash of 1 on 1. That is also true, because that is the same as B, because it's 1 and 1 on 1 is just 1. And then if you look at that, that's the only option that is left, but that's g dash of 1 is equal to minus 1 on f dash of 1. That means that you flip them and they are reciprocal, which is not necessarily true all the time. It's not always true. It is true when the gradient is 1, but we can't be certain that at that point the gradient is 1.